Welcome everyone to another Leetcode problem discussion. And today's problem is problem 380, insert, delete, and get random, all of them in order of one time. Okay, so the problem, we have to understand the problem description to build it step by step. So we have to implement a randomized set class where the randomized set, this constructor initializes the randomized set object. And then there is a method insert. So this method will insert a value into that randomized set. And if the value is not present, it will insert the value and return true. But if the value is already present, and we try to insert it again, it returns false. Okay, so next one is remove. In order of one time, it will remove any value. But if the value is remove any value and return true. But if the value is not present, so if we try to remove something that is not in the randomized set yet, it will return false. And the final thing is get random. So get random will randomly return any value from the randomized set. And every element that is present in the randomized set will have the same probability of being returned. Okay. So one of the most important thing here is like all the things like insert, delete, get random, all of them all of these functions has to work in average of order of one time complexity. Okay. So before we approaching the problem, some of the questions that we may have, like for the interviewer, one question might be like, hey, what if we know that if there is no element yet in the randomized set, we cannot remove it. Yes, we will handle that. But what if there is no element in the randomized set and still we try to get random, right? What will happen then? Because this one doesn't return Boolean, this returns just a value. And if there is no value, what will happen? So it's addressed here. It says that when the get random will be called, there will be at least, like you see it here, right? There will be at least one element when the get random call happens. Okay, so that's here. Okay, so let's talk about the strategies. Now, since everything has to be done in order of one time, I think the first thing that comes into mind is how about using a hash map, right? Or hash set. Okay, so we know that insertion in a hash map or hash set is order of one time, right? So it's simple, say if I want to insert any value, say insert anything like 1 and then insert 2, then again try to insert 1. So what's going to happen is in the hash map or hash set, let's say we have a hash set, we are going to insert like 1, right? And then 2. So all of these will take like order of one time. And then we again try to insert 1, but it will check and see 1 is already there. And so it won't insert. And this checking, that one also takes order of one time. So everything is fine. That's fine. Now, what about remove? Let's say we have it and then we try to remove, say, anything, say 3. Now it will go and check if 3 is there. No, that checking takes order of one time. So we'll return false, right? So in order of one time, that can be done. Also, let's say we want to remove 2. So in order of one time, it will go and check and see, oh, 2 is there, and then it will remove it. So that is also being done in order of one time. Okay, so insert, remove, everything is perfectly done in a hash set. Now the problem is, say, Okay, so let's say do this thing. Let's insert another two things, 4, 5, and 4. So 5 and 4 is going to be here. Now, the thing is, if we do the like get random, now get random is actually being a problem because the thing is, we don't have any random access. So you can see that no random access, right? That means I cannot just say go to the position 3 of the hash set or position 2, like index 2. So these numbers are not indexed. So in a hash set, these values are not indexed. So what will happen is if I try to like remove any element, so there is no order of these elements, right? So if there is no order of the elements, how do I randomly just select one? So if there was an order, say 0, 1, 2, and then we could just say, okay, I want to get the first element or index one element and just could directly go there and do my stuff. So here is the issue. In a hash set, there is no particular order of the elements, and also uh, we don't have any random access. So it cannot be done in order of one time. So order of one time is not possible in a hash set. So now comes into the picture. What about if we had a array list, right? So if we had an array list, say if we have an array list, so we call the array list. In that case, we could know that, say, if everything was in an array list, say 1, 5, 4, right? So in an array list, the advantage is I have random access. I know the indices. And then randomly, I just randomly like use the random function. Say we have a random object. And then we just call the next int, right? With the value of 3. So it will return any value between 0 to 2, right? So we get that value. Let's say that value is 0, right? So what we can do is we can just directly go to the 0th index and remove that. Okay, so it can be removal. Sorry, not remove that. We can just go to that index and return that, right? So in order of one time, I can just this whole thing, you see, I am just getting the random index and I can just directly go because I know the size of the, like, this is the size of the array list, right? Array list size. So I mentioned the size of the array list, 3. It will give me any value between 0 to 2. It will give me 0. And then I will go to that 0th index and return that value, right? So return 1. And this whole thing can be done in order of one time. Now here is one thing. If okay, so you see that get random can be solved with order of 1. So can I use array list for also for insert and remove? So here is the thing. For insert, you see that for insert it may look fine. Let's say I am going to insert more values, say 7 and then 1. Okay, 7, that's fine. It is inserted in order of one time because every time it's getting inserted at the end. But when you are actually it's not fine. It's not fine. I'm wrong. So it's not fine because although before adding 7, I have to actually check if 7 is already there, right? So that means I have to do this check, and this checking actually itself will take order of n time. So I cannot, insertion is not being done in order of one time because I cannot insert a value that is already there, right? Okay, so insertion is not working. And also removal, we say remove any value, remove 4, remove say 7, right? Now you go here and you have to check if 7 is there. So you have to check here, check here, check here, right? So it's order of n time to check where 7 is, right? That's another issue. So removal also cannot be done in order of n time. Okay, so you see that GetRandom problems get solved in array list because it has random access. Array list, we can just jump to any index. We know the size, we can randomly generate an index, but the insert and remove cannot be done in order of one time. So let's do this. Why don't we just combine them two? The best thing here is if we can have a hash map. In the hash map, I will have like key value pairs. So the key is going to be the value, and the value is going to be the index in the hash map. Sorry, index in the array list. And this is my array list. Okay. So this is my array list. So we combine these two to do all the operations in order of one time. So first I want to insert one. So what I do is I first go to the hash map and ask, hey, do you already have one? No, it doesn't have one. So I just go here and add one. I know that the index is 0 and add that thing like value of 1 and the index in the hash map, right? Okay, so everything is done in order of one time, right? Next, 2. So in order of one time, I ask, hey, if 2 is there, it says no. So it just goes here and adds 2 at the end of the array list. This is also done in order of one time, and then I add it here, right? Say at index 1, okay? Yep, next 1. So I go and check, hey, is 1 there? In order of one time, it says yes. So I don't add this, right? This time I return false. Now remove. Before removing 3, I go and ask, hey, is 3 there? No, the 3 is not there. So I don't do anything. And I just return false, right? Okay, next, 2. Yes, 2 is there, and it gives me the index, which is 1. So I know where I have to go, right? So I just jump to this first index and delete it, right? So I delete it, and this is done in order of one time, okay? Next, insert, say, 5. So 5, I check here, it's not here, so I add 5 here. Okay, so after deleting the 2, I also have to delete from here. So 5, let's say I add it, and then I put the index here. Next, I add 4. I just check here. I don't find it. So it's fine. So I add it here and add the entry here 4 and say 2. Okay. Next, this is an important one. Let's say remove 1. Now, I come here and I see that, okay, first I check, right? I check here. Yes, 1 is here. Index is 0. So it returns 0. So I go to this. I know now that I have to remove from here, right? Now, if I remove from here, now you see what is going to happen is everything, like there is an like empty place here, right? So I cannot do that. So a good idea is what about like swapping? Like, no, instead of swapping, I can just say, what about just, yeah, let's do the swap. So 4 comes here, 1 comes here, right? And then what I do is I just update the index for 4. So index for 4, I update it with 0. And then I remove the last element. Okay. I remove the last element and remove it from here. So all of these, like I'm doing in order of one time, right? Checking first, then going to that index, then doing a swap, right? And then removing from the last element, and then removing from the hash map. Everything is in order of one time. So you see, combining a hash map with an array list, now everything is in order of one time. So here is one thing why this is an average of order of one time. The thing is, in an array list, you know that the size of the array list is not fixed. What the compiler does is it allocates memory for the array list, and if the array list is already full, it actually adds more memory. But the amortized operation, if you read about the array list, the amortized operation is order of one. Okay, so anything you do on an array list is on average order of one. So I hope now you understood that combining a hash map with an array list, how actually this works. Now the next thing is like say if we have a get random thing, let's say we inserted another one. Let's say we inserted like 10. So I checked if 10 is there, no. So I add 10 at the end, make an entry for 10 with index 2. Okay. Now I call this get random thing. Now for the get random, what I have to do is I have to use a random object, like, so I create a random object and say we call it rand, and then I call this function nextInt, and there I mention the array list size. So array list size, now the array list size is, 3 here, right? So it will give me a random value between 0 to 2. Say this value is 1. Okay, so what I do is I just come here and return 5. Okay, so get random will give me 5, and this is done in order of one time because I know the size of the array list. So let's go and check the code. You see we have a hash map, and then we have a array list of integers. The hash map is like value and index in the array list. Then we have a random object. So the randomized set constructor, it initializes the map, the array list, and also a random object. Insert, first I have to check if the value is already not in the randomized set or not in the map. If it's already in the map, I return false. Otherwise, I add the value to the array list. Now I know which index it is in. And then I know that this is added at the end, right? And then I add it to the map and the index, which is the end index, okay? And return true. That's simple. The tricky one is the remove one. Before removing, I have to first check if the value really exists. If it exists, then I first go to the map and get the index in the array list, okay? And then in the array list, what I do is at that index, I just replace the value with the last value. Okay, I replace the value with the last value, and then what I do is so the last value now has the last value or the end the last element of the array list now has a new index, right? So I have to update the index in the map for that value, right? And then I remove the last element because the last element already has been swapped with the index at the element at the index. So I remove that. And finally, I remove this value altogether. Okay, so that value is now, this value is now replaced in the array list with the last element, and the last element index is deleted, and the last element value is updated in the map, and then we remove the value from the map. So everything is deleted. These values now deleted both from the list, array list, and as well as the hash map, and then we return true. For the get random, I just generate a random number depending on the size of the array list. it will give me a value in the range of the size of the array list, and then I just return based on that random number that I got. So if I submit this, you see everything is in amortized order of one thing, and this is actually runs pretty fast. So thanks everyone for watching. We'll come back with another problem soon.